So today we have a 2000 Ford Excursion with a diesel engine here. I think this is a 7.3 diesel, and it's here for a hard start cold problem. So the first thing I'm going to do here is set up the amp clamp over the glow plug controller wire and record the current that the glow plugs require, or actually take, to see if the glow plug system is functioning. I find that to be the most effective approach, and then we'll, if the current is low, then we'll individually check the glow plugs. At the same time, I'm going to set the scan tool up to record actuation oil pressure during cranking and engine RPM. So we'll get that set up and we'll give that a try. I'm not worried about having to watch this graphing meter because it's recording right now. I'm just going to zero the amp clamp. There we go. Half an amp right now. Okay, so we'll set up the scan tool now. So that's a good start. First thing we noticed is that the glow plug controller did not energize. So we had no current flow. So we obviously have no glow plug. So that'll be a huge hit on starting this thing. So we're going to check this controller circuit. I'm pretty sure that one wire is grounded all the time, and this is the control here, but we'll double check that, get some test equipment out here. Okay, so I see he's got an aftermarket glow plug relay. That's this one here. I wasn't checking that one, I was checking this one, which I believe is the intake heater, but they both should come on simultaneously. I'm going to recheck this. I never heard any relays clicking on, so I'm suspicious that the control circuit is not functioning here. This red wire should be power. I'm going to have to look at this one to see how it's designed. I'm going to get a picture of the wiring diagram here. So here's a picture of the glow plug relay and the intake manifold heater relay. They both have the same power supply from the right side battery, and looks like the red wire would be voltage or power. Yes, 12 volts, it says right there, 12 volts on it. And we're going to make sure that that has 12 volts, and the ground side controlled by the PCM. So there is a possibility the PCM thinks the engine's warmer than it actually is. We haven't looked at data yet. We're going to see if we've got power on both these two red wires at the glow plug controller and the intake heater. And then we're going to look at engine data and see if the PCM is recognizing the correct coolant or air temperature, whatever it uses for, could be coolant, air, or oil temperature that it uses to establish whether it should activate the control, the glow plug heater and the intake heater. But they're not coming on, and that's going to have a huge impact on startability. Customer did say it starts reasonably well if it's plugged in. So the power supply for both those two large relays comes from circuit 361, the red wire, and that is supplied power from the PCM relay. I'm sure that relay is working or the vehicle wouldn't even start, because that relay supplies power to the powertrain control module. So we want to make sure we have power there at the glow plug controllers. Sorry, one more, this one here, on this circuit with the key on, and then we're going to look at data. So with the ignition key in the run position, I do have power on circuit 361, the red wire on the intake manifold heater and the glow plug relay, and we have 12 volts on the control side of it as well, which means there's no ground. So let's look at data. First thing we're going to do is check for memory codes here, see if we have any. Oh, look at that. Glow plug, glow plug, glow plug, and ICP pressure above normal. Well, high ICP pressure won't cause a no start, but these glow plug issues might. So I don't know if those codes were generated recently. Let's clear them. I haven't cranked this thing yet. And exit. And let's do key on engine off self-test. It'll probably flag a code for being too cold, but it should test the glow plug circuits. Internal control module ROM error, but no glow plug codes. Alright, we're going to look at data. So I'm looking in the data list here, and I see engine oil temperature at 4.4 volts and 3 degrees Celsius, which is about right. Intake air temperature 5 degrees Celsius. And let's see if we can find engine coolant temperature. I don't see it in here. Intake air, oil temperature, no, I don't see it. I'm going to build a custom data list. Deselect everything. I'm going to go RPM. Oil temperature. Might as well take it in voltage as well. Glow plug percentage, glow plug time. Intake air temperature, ICP, injection control pressure, and the regulator. And I guess it doesn't have an actual coolant temperature in this data list. So the temperatures look reasonable. Let's see if it's actually commanding the glow plug on time. Right now it says 0. I'm going to cycle the key. Hopefully we don't lose the data list. Yeah, see, it's commanding it on, yet it's not working. So hard to see the dash indicator in here with this sun shining in here today. Well, it's commanding the glow plugs on, but it's not, doesn't appear to be working. Look for a bidirectional test here. So here is a glow plug test, including power accessories. Continue. Battery voltage must be 11.8 to 14. Test abort. It's supposed to do this test running. Well, let's put a test light across that circuit. There's no other bidirectional control of output state. What does that do? Engine off, turn off AC and all accessories. Release accelerator. Okay, so that should energize various. You can hear the lift pump running. And every time you cycle the key. To press brake pedal. Alright, well that doesn't do it. Well, let's see if we got a ground on that glow plug controller. So I've determined that the PCM is not supplying the ground to the glow plug or intake heater for whatever reason. So I've got a remote start button hooked up so I can remotely ground those two relays. When I do, the glow plugs draw 160 amps and the intake heater I think was 35 or 55, I can't remember. So I'm going to start looking at data here. I'm going to simulate a normal operation of the glow plugs and then see how this thing starts. Get set up here. Sorry for the glare here. This it's quite bright. So where's actuation oil pressure, injection control pressure right there. This needs to hit at least 500. Okay, so I'm going to put the glow plugs on. should be enough time, I would think. We got oil pressure. We got 500 pounds of oil pressure. Let's try cycling the glow plugs again. It's certainly not cranking very fast. Where was engine RPM? 106, that's not fast enough. No, it's never going to start. It's not cranking fast enough for one thing, but the glow plugs aren't working. The battery voltage went so low it stopped the scanner here. So let's get a booster battery out here and see if we can try again. Okay, so I got a booster battery hooked up to the right side main battery, and I got the jumper switch set up to bypass the PCM control of the glow plugs and intake heater. I'm going to turn them on now. I believe they're on. 1003, 1004, 1005, 1006, 7, 1008, 1009, 1010. It's got a miss in it now. Blowing a little bit of white smoke out the exhaust. See the white smoke? So it's got at least one glow plug maybe not working. It's also got a knock in it like an injector issue. Well, at least we can get it in the shop now and work on it out of the sun here where there's less glare. So it's in the shop now, semi-warm. I ran a cylinder contribution test and it fails number 8 cylinder for balance. It also has this intake heater fault code. So there's a problem. There are multiple problems with this thing. There's either wiring issues or driver issues for the intake heater and glow plug control circuit. It has an injector knock. It might have low compression in one or more cylinders. We'll have to do further testing. And the batteries didn't allow it to crank fast enough to start if it had everything else going for it. One thing it does have though, we're going to look at the data that I recorded here. So I retested this aftermarket glow plug controller and it is being commanded on by the PCM. And initially draws over 200 amps. Mind you, now I have a battery charger hooked up to it. So the battery voltage is a little higher, so the current would increase. But this intake heater relay is not being commanded on, so we're going to have to check the quality of that circuit back to the PCM, and it's setting a fault code for that circuit as well. The other issue is the batteries are just weak and it's not cranking fast enough. We'll have a look at the data that I recorded on that cold start. So here's a review of the data that was recorded during that starting event, and even with the booster battery hooked up to it, you can see that the current RPM here during cranking was only 106, 84, 90, 100, 130, 114. This thing should be cranking at about 200 RPM. RPM is critical on a diesel because of heat of compression. Low RPM, low heat. The good thing is, even at its lowest initial crank, we had 517 pounds of actuation oil pressure. So fortunately, it doesn't look like we have a high pressure oil leak in this system. It's making oil pressure, but it's probably not making enough compression temperature because of the low RPM and the weak batteries. That, coupled with the lack of the intake heater, is really causing an issue. Now, there is a noise in the engine when it's running. We'll explore that once we get a little further here. I'm at connector 138 on the right valve cover. I'm going to check continuity of the wires. So we're looking at this electrical diagram, and what's of concern here is this violet wire from the intake manifold heater relay. It goes through connector 138 here. Let's see where connector 138 is. Obviously it's under the hood. 135, 138, so it's over on the right valve cover. That would be a good place to examine that wiring right here. connector 138. Let's go back. Oh, I lost the diagram. So we'll have a look at that connector and that violet wire and check continuity from the glow plug controller, I'm sorry, the intake manifold heater to that connector, and then from there to the PCM. So there's connector 138 on top of the left valve cover underneath the air induction. So I've got the air filter and air intake hose off. So we're going to check continuity of the wiring from that connector over to the actual intake heater relay, and that is the violet wire, pin 26, circuit 462. So we'll identify that and check continuity of that wire. So we've got the ohm meter hooked between pin 26 and the control side of the intake heater relay up to connector 138, and it reads 0.04 ohms. So that wire is good up to there. So now we got to check it down to the damn computer, which is down inside the fender down there. There it is, way down there. Oh damn. I wonder which one of the connectors it is on the computer. Maybe I can get it apart. I don't see anything physically wrong with the wiring at this connector here. I looked at the back one. So pin 26 is the third row down, second pin in, that's 27, that yellow one on the outside there, and then the next one in. And I don't see anything physically wrong with the wiring, but it very well could be open in here. You got to remember, these wires move with the engine and the vibration of the vehicle. So we'll get the connector apart on the ECM and check the continuity there. So I decided to look up the theory of operation here. It says for the intake air heater to work, the ambient temperature must be below 0 Celsius or 32 Fahrenheit. So it was like +3 when I was trying this. So it may not have been cold enough for the intake air heater to come on. Oil temperature has to be below 55 Celsius, which it was. Between 11.8 and 15 volts, probably not because the batteries are so weak. And automatic transmission must be in park or neutral, and glow plugs must be off. So it looks like the intake heater only comes on after the glow plug cycle off. But I do have a fault code in the computer for the intake heater. If I can get this file to open, for the intake heater circuit, and it reset that code after I cleared them. So it did reset that P0541 code after clearing them, after clearing the codes as well as cylinder A contribution. But I'm going to see what the troubleshooting chart suggests for P0541. So here's the troubleshooting chart from Ford's pinpoint test. It says 541 is an open circuit. It's monitoring the circuit here to pin 98 of the PCM, circuit 462. Here it says it's pink when it's actually purple or violet, I think. So it says to go to pinpoint test KL4, and if we open that up and look at it, it says check continuity of the wire, which is what I'm doing, from pin 98 of the PCM to the actual intake heater, and if that's good, replace the PCM. So we're going to hopefully find a problem with the wiring. I'll get a pin out for the connector at the PCM. So the PCM is actually inside the left front wheel well. So the best way to access that is to raise it on a hoist, take the fender skirt out, left front wheel and fender skirt out, so we'd have to go to that. But now that the battery's charged and it's cranking a little better, I want to do a relative compression test to see if we've got a serious mechanical issue in this engine before we get carried away here. So I got the graphing multimeter set up to record 1000 amps over 1 second, and I've got an amp clamp over the battery cable going to the starter, remote start button connected to the starter S terminal, starter solenoid S terminal I should say, and I'm going to crank it and have a look at cranking compression or relative compression. Here goes. Listen to the cadence of the engine. Well, that didn't work. What happened now? Oh, I didn't have it in record. Let's try that again. Somehow I turned off channel 1. one of the benefits to this is that we can pause this and replay it and have a look at it. So you can see there's one lower one there, two lower ones. So 1, 2, 3, 4, 5, 6, 7, 8. So that's one revolution of the engine and 8 compression events. 1, 2, 3, 4, 5, 6, 7, 8. So there are two lower ones in here, which indicates that it's got a mechanical issue in a couple of cylinders. Repeats consistently. So we kind of knew this engine was a little tired. It does have some blow-by. I'm going to remove the inner fender skirt now and check continuity on that intake heater relay circuit to pin 98. So there's the left inner fender skirt out, and it is pin 98, which is that one right there. That's 104 at the end. 103, 102, 101, 199 is empty, and 98 is right there. Now I don't see anything wrong with this wire here, but we're going to check continuity from this wire back to the PCM, or back to the intake heater relay. Well, that's not good. We have continuity from this pin to the intake heater relay through that wiring harness. I'm going to graph it while I wiggle the wires just to see if there's anything missing, if it drops out. So I've disconnected the control wire from the intake heater relay, and I'm going to try to rerun this self-test to see if it faults it. Why did it abort the test? Tangent off test. Did I click the wrong one? If it's actually testing this circuit right now, it should show up on the scan tool as a current fault code. It is. So did I inadvertently fix this problem by cycling the connector at the ECM? Damn, I hate the intermittent problems. Well, we're going to put it back together. So I reran this key on engine off test using Ford IDS, and it came up with this 1391, 1393 codes, which are problems with the glow plug circuits. Now, this vehicle is California emissions. It's originally from BC, and it's a unique vehicle because it's listed as California emissions. And if I look up the troubleshooting chart for 1391 and 1393, the California emissions circuit has some feedback wires from the glow plugs back to the PCM, and it says California and 49 states, the on time is dependent on the temperature. Let's see what I was looking for here. Previous diagram here. 1391 is set when the monitor indicates that all 4 glow plugs are not being powered on the bank, and open in the glow plug circuits. Glow plug relay, glow plug monitoring circuit could be the possible causes. I believe this customer said he changed the valve cover gaskets, and I'm wondering if they might be different for California emission vehicles, because going through this troublemaker chart here it says, I read it someplace that said that only the California emissions system, here it is, glow plug monitor self-test California and 50 state only is a functional test of the PCM performed on demand when the engine is running. So I'm going to look and see if there's a difference in those valve cover gaskets which contain the circuits for the glow plugs. When I measure the glow plug current, it indicates that they're all working. So I checked with the Ford dealer, and the valve cover gasket's only listed as 1. For some reason he couldn't decode this VIN, but it is definitely say California emissions on the hood. As I mentioned, the vehicle did come from BC, so they often have California emissions because of the close proximity to California. My understanding is these monitor codes only exist on California emission equipped vehicles, so I don't know if this has something to do with the tuner, if it has something to do with previous repairs in it. I know the glow plugs work now. I'm going to talk to this customer and see if we can get some direction. So I found some information on the P1391 and 93. I was right. According to Ford, this circuit is only used on California vehicles, and it's basically 3 small wires protected by fusible links at the glow plug controller, or the glow plug relay, and make sure they're on the right terminal. So I'm going to have a look at that. So here's the glow plug controller. This is the input wire coming in. We don't have a ground. Well, it don't matter. This is the main feed wire coming in. This is the output wire to the glow plugs. Brown to the left side, the yellow to the right side here. And then there are the 3 fusible links that you can see here attached to the monitoring wires. Now it mentions something about there being a shunt, and I would imagine expects to see a voltage drop across that shunt based on the current flow. But I don't know if that's been removed or modified, because this is not an OEM glow plug controller. We're going to have to find out. I don't think those fault codes are going to create a problem other than turning on the MIL after 2 drive cycles. We'll see if we can find any more information on this shunt circuit. Okay, so here's what I've come up with. When they removed the factory glow plug relay, which looks like this guy right here, they did not install or transfer this shunt bar to the, looks like a White Rogers relay that they installed. So it's missing this shunt, and the way this thing works is the computer is going to measure the voltage on the output terminal of this relay, and it's going to read a voltage drop across this shunt here on the left side and the right side, and if it sees a voltage drop obviously affected by current flows from the glow plugs, it would know the glow plugs are theoretically working properly. What they've done is they've connected all 3 of the output wires plus the 2 glow plug control wires to the same stud, so of course it's not going to see a voltage drop. I checked with the Ford dealer, and I was able to find the part. They call it a shunt, and the part number is a DY840, but I'm missing the Bakelite stud location. I don't know if I could make that circuit work. Plus there's not a lot of room back there for this thing. I'm going to see if the customer still has the original glow plug relay. So here's what I did. It's missing the shunt, which is a little metal strap with an insulated stud, and the left and the right glow plugs go off of each insulated stud. There is 1 wire, I think it's yellow with a green tracer, that goes to the middle stud, which is a feed. So I simulated a voltage drop by wiring in 2 194 side marker pigtails, and it runs the glow plug control test now and passes because it sees a voltage drop on the output circuit, thinking that the glow plugs are functional and there's a sufficient current flow. It's not the proper fix, but it'll get it past setting a fault code and turning on the check engine light. And if the glow plugs are working, that's all that's really important anyways. So we're going to put this thing outside. I put 2 fresh batteries in it. We're going to put it outside and see how it starts in the morning. So another advantage of this workaround here is that these 2 little 194 marker pigtails are going to act as a test light to tell me when the glow plugs are working, or anybody else. To cycle the key, I think the glow plugs will come on. Well, the wait light came on, but I didn't see the indicator light come on, or these 2 lights come on. Well, we'll see how it starts tomorrow. So I ran a cylinder contribution self-test using Ford IDS, and it comes up with the same information the Snap-on scanner gave me. Cylinder 8 contribution balance. It has a bit of a lift or a injector type knock. Now that problem could be injectors, but
the relative compression test suggested there were at least 2 cylinders that were a little bit lower in compression based on the current draw. So this thing needs some mechanical repairs in the engine, as it suggests here, compression rings. But, well, we're going to start with a couple of batteries, I believe, and see if it improves cold starting tomorrow. So I was going to try to repeat this relative compression test and sync it with one of the injectors, but I have no way to disable the fuel system and not have it start. You need injector pulse for a sync, but if you have injector pulse, it'll start. But I took the oil filler cap off, and if you watch just what happens at the oil filler cap during cranking and listen to the cadence in the engine when it's cranking, you can tell that there's this significant compression issue in at least one cylinder. And if you look at the waveform here, you can see there's a couple that are low. In addition to that, it sets a fault code for cylinder contribution on cylinder 3 and cylinder 8. And cylinder 3 and cylinder 8 are 4 cylinders apart. So that could be 3, and then the next one down here would be number 8, or vice versa, it doesn't matter. So this engine needs major engine work. Okay, I'm about to start this truck again after a cold sight. Wait, lights off. You can hear the cadence of the engine. There's at least one cylinder, probably 2, that are misfiring. Definitely crank a lot faster. We'll have a look at cranking RPM on this recording here. $180. That helped with the fresh batteries in it, but the engine's just tired. It's about as good as it's going to get.